Hi guys, welcome back to our course on NumPy. In our last lecture, we did some examples on array filtering, and today we are going to study how to calculate mean, median, mode and standard deviation using NumPy methods. So let's get started. So as you must be knowing, mean, median and mode are the measures of central location of data, and standard deviation gives us the extent of deviation of the data about the central location. These measures are of utmost importance while analyzing any data. So let's get started with the coding part. Let me open my terminal. So I'm going to write Python 3, hit enter. Now I'm going to import NumPy as NP. So first of all, let's talk about, or let's take a look at the measures of central location. So as you must have studied in statistics at some level about the measures of central location. So there are three main measures of central location. They are mean, median and mode. As we know, the mean refers to the average value of the data. Similarly, the median refers to the middle value of the data. So median divides the data sets into two equal parts. And finally, the mode refers to the most common value. It is also known as the most repeated value of the data sets. Now let's calculate the measures of central location using NumPy methods. For that, we need to create an array first. So let's create an array and calculate all three measures of central location for that particular array. So I'm going to create an array with name x. So x is equal to np.array, and I'm going to pass a Python list. So this is our data. So it can contain any random values, but make sure that it has some repeated values so we calculate the mode. Otherwise, it will be a multimodal data set. Now let's start with calculation of mean. So let's first calculate mean, and we are going to use the standard formula. So what is the standard formula? Standard formula is the one that you use. Like you calculate the sum and you divide by the number of samples or number of observations. So this is not a NumPy method. It is the general formula that we use or we are using since 4th or 5th grades. So we need to find the sum of all the samples or all the values, and we have to divide by the number of values or the number of samples. So let me just add all the values and divide it by the number of values. So what is the number of values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have total 15 values or 15 samples. So I have to divide by 15. So divided by 15, close the bracket and hit enter. So this is the mean, that is 3.533333 and so on. Now let's use the mean method, which is the method of NumPy. So I just need to write print np.mean, and I have to pass the array name. We can see that we obtain the same result in both the cases. So I don't need to add all the values and divide it by the number of values, because if we have a very large data set, it will be difficult. So it's easier to use the standard method offered by NumPy. Let's calculate median now, which is the middle value. So to calculate the median, we should have a sorted array. Now the question arises that why do we need a sorted array? So if you are in a state to recall the method you followed in your primary school, that we just need to sort the array in a sorted order, whether ascending or descending, and we just need to circle out the middle value. So you need to count from beginning and count from back, and the value where you meet by taking unit step at a time, so that value will be the median. And in case you get two values, it will be the average of those two values. So here I have obtained the array in a sorted order using the sort method of NumPy. Now the middle value, as you can clearly see, is 3. So median of this data is 3. Now let's use the median method. For that, I just need to write print np.median, and I need to pass the array name. So as you can see that the answer is 3. So now let's calculate or move on to mode. So let me just obtain the sorted array again. As you can clearly see in the sorted array, 2 is repeated 5 times. So it is the most repeated value. So mod of this data set or data is 2. Now let's use the mod method. Now the procedure is same. Print np.mode and pass x, but you got an error this time. So here's the catch. NumPy does not offer any method to calculate mode. So there is no inbuilt method in NumPy to calculate mode. So you must be wondering how to calculate mode then. I'll get back to that topic in a while. First of all, let's explicitly mention this error, because there's a very high probability that you will make the same mistake and get the same error while calculating the measures of central location, because other central location measures can be calculated by NumPy methods, but for this you need a SciPy method called as mode. So I got an error because mod is not an attribute of NumPy, it's an attribute of SciPy or scientific Python. We'll discuss this library in detail later on. We will create a separate playlist for SciPy. For now, just look at what I'm going to write and copy paste the same thing in your command prompt or your terminal or whatever IDE you are using to implement this code. So from SciPy, import stats. So stats is a module of SciPy. So print stats.mod x. So the result is 2 and the count is 5. This shows that the mod of the given data is 2 and it has occurred 5 times. So it shows the mod as well as the count of that mod. Count just refers to the number of time a particular value occurs. So don't be worried for now. Just copy paste the same thing. If you're not able to understand, it's not a big deal. We are going to explain it in detail later on. Now let's move on to calculation of standard deviation. Standard deviation is a measure of deviation, dispersion, how much the data deviates from the central value. In this case, it's going to be mean, because you can calculate standard deviation around mean, median as well as node. But this inbuilt method is only for mean, because most important measure of standard deviation is standard deviation about mean. So I just need to write print np.std and I need to pass the array name and I got the result. And this is the most important thing to note, that it gives the standard deviation about mean. Now I have an assignment for you. Calculate the standard deviation using the correct formula. So this time you don't need to use this inbuilt method. You just do it using the standard procedure that you follow in probability and statistics, and please match both these values. They will be same, but I want you to calculate it manually so that you can verify the result. And you need to check whether the theoretical value coincides with the calculated value. So in today's lecture, we covered the measures of central location, that is mean, median and mode, and we also demonstrated the use of STD method for calculation of standard deviation. That will be all for today. This video is brought to you by Programming Knowledge. Please like, comment, share, subscribe and hit the bell button for updates, and stay tuned with us for next lecture. Thank you.